X to the 0 power, what do we think x to the 0 power equals? Well, a lot of people would answer that it is 0. But however, x to the 0 power equals 1. X to the 0 power equals 1. Well, how is that even possible? Sure seems like if you don't have any x's, it should equal 0. It goes back to the rule that we just learned at the start of this lesson, that when you divide exponents, you subtract the exponents. So let's say, for example, I have x to the 4th over x to the 4th. So according to our dividing exponent rules, I should subtract the exponents, and that would be x to the 0 power. Also, back in elementary school, you learned that if you take anything divided by itself, what should that equal? Well, that should equal 1. Anything divided by itself is always going to be 1. In a fraction, any number over itself is always going to equal 1. So if x to the 4th over x to the 4th equals x to the 0, and x to the 4th over x to the 4th equals 1, then it stands to reason that x to the 0 power must equal 1. They have to equal 1 to keep all the rules about dividing a number by itself and dividing exponents consistent to each other. So by definition, and this is how you can prove it, x to the 0 power equals 1. For any non-zero number a to the 0 power equals 1. So 15 to the 0 power, well, that equals 1. c to the 0 power, well, that's going to equal 1 because everything to the 0 power. 2 sevenths to the 0 power, well, that equals 1 too. I mean, again, anything to the 0 power. I could have 1 million to the 0 power, and that it still equals just 1. Anything to the 0 power equals 1. So let's look at these expressions. This one says negative 4n squared q to the 5th r squared, 9n to the 3rd q squared r, all to the 0 power. Well, everything in that set of parentheses is going to be taken to the 0 power, which means the answer is just simply 1. Don't have to go to each piece and take those all to the 0 power because they're all going to be 1s anyway, and 1 over 1 is just going to equal 1. 3a doesn't have the parentheses like that. 3a has b to the 4th, c to the 2nd, d to the 0 over b to the 2nd, c. So we can divide our b to the 4th divided by b to the 2nd right there. And when we do that, that's going to be b to the 2nd because 4 minus 2 is 2. I have c squared divided by c to the 1st right there. And c squared divided by c to the 1st is just c to the 1st, or just c. And then d to the 0 power, well, d to the 0 power would equal 1. And I really don't need the 1 there because if I take b squared c times 1, I still just get b squared c. So b squared c would be the answer to that. Let's look at x to the 2nd over x to the 5th. So according to our division rules, we should subtract 2 minus 5. So when I take 2 minus 5, I get x to the negative 3rd. Well, what does a negative exponent mean? Let's explore that for a little bit. X to the 2nd literally means x times x. X to the 5th means x times itself 5 times. And if I start canceling parts out, I get nothing left in the numerator, so I do need to put a 1 there as a filler, over x times x, which is x to the 3rd power. So by using our subtraction rule, I get x to the negative 3rd power, and by using this cancellation method, I get 1 over x to the 3rd. So that's what a negative exponent means. Negative exponents are reciprocal exponents. If you have a negative exponent, it is the reciprocal of that, which means it moves to the bottom of a fraction. If that was already at the bottom of a fraction, you would move it to the top of the fraction. So here's a couple examples in the gray box. 2 to the negative 4th power, I would take that 2 to the negative 4, move it to the bottom of a fraction. I would get 1 over 2 to the 4th power, and then I can simplify that to 1/16. Or notice in this case, the j to the negative 4 is at the bottom of the fraction, so what happens is it got moved to the top of the fraction, and so that becomes 1 times j to the 4th, which is just j to the 4th. So if it's at the bottom, move it to the top. If it's at the top, move it to the bottom. An expression is considered simplified when it contains only positive exponents. Each base appears exactly once, and there are no powers of powers, and all fractions are simplified in simplest form. So to be simplified, no power of powers, you shouldn't have two exponents on one base. The fraction should be simplified, and this should have no negative exponents in it, only positive exponents. So example number 4 says n to the negative fifth, p to the fourth over r to the negative 2. I only have unique bases. There aren't any multiple of the same variable bases, but I do have several negative exponents in there. So I'm going to take all the negative exponents and move them to the other portion of the fraction. So that means that the n to the negative fifth, since it's a negative exponent, will now be moved to the bottom of the fraction, and when you move it, it now becomes positive. So now it's n to the positive fifth. P to the fourth is just going to stay right where it's at because it's a positive exponent. It's going to remain on the top. But r to the negative 2 needs to be moved to the top. And when you move r to the negative 2 to the top, it now becomes r to the positive 2. Part B has 5 over negative 20, and then r to the negative third, t to the fourth, and then the new denominator r squared, t to the seventh, u to the negative 5. So I'm going to start out by dividing 5 over negative 20. 5 over negative 20 reduces to 1 over negative 4. And then I have r to the negative third divided by r to the second. So that means by following my division rules, I should be taking negative 3 minus 2. And negative 3 minus 2 would be negative 5. So that's going to be r to the negative fifth. I'm going to leave that on top for right now. And then I have t to the fourth divided by t to the seventh. So that means I should be taking 4 minus 7. And that is negative 3. So that means I have t to the negative third. And then I got u to the negative fifth, which there are no u's on the top to divide it by. So I'll just leave u to the negative fifth on the bottom. Don't leave any negative exponents in your answer. And since we all have all negative exponents, I need to move some things around here. So that's going to be still 1 over negative 4. R to the negative fifth will go to the bottom as r to the positive fifth. T to the negative third goes to the bottom, becomes t to the positive 3. And the u to the negative 5 on the bottom is now going to move to the top to become u to the positive 5. And I really don't need that 1 there anymore because I do have u to the positive 5 on top. So I'll just erase that. So I have u to the fifth over negative 4, r to the fifth, t to the third. Last example is very similar to that. I do need to simplify the fraction 2/10. That is 1/5. I'll have a to the second divided by a to the negative third. So that means I have be taking 2 minus negative 3. Well, remember, if you got 2 minus a negative number, that's the same thing as adding that positive number. So that is actually a to the fifth. I've got b to the third divided by b to the negative 1. So that's going to be 3 minus negative 1, and very similar to what we did previously on subtraction. This change the minus to a plus, change the sign of the number. So that actually is going to be 4, so b to the fourth. And then I have c to the negative fifth divided by c to the negative fourth. So that time I'm going to be taking negative 5 minus negative 4, and yet again, change that to a plus. But I'm taking negative 5 plus 4 now, and that's going to be negative 1, so that means I'm going to have c to the negative 1. So that means I only got one more step to do. I'm not going to need that 1 in front of the a to the fifth, because the a to the fifth and the c to the fourth will remain at the top of the fraction, but that c to the negative 1 needs to move to the bottom of the fraction. That's b to the fourth. That c to the negative 1 will move to the bottom of the fraction with the 5, so it becomes 5c to the positive 1. But remember, a positive 1 is not necessary. A negative 1 is, but not a positive 1, so I will go ahead and erase that, and there is my answer.